1, and we're going to look at the base and the height of each parallelogram. So for question 1a, if our base is 12 here, then what's our height going to be? Is it going to be this line over here on the side that says 5 centimeters? Well, the question becomes, is that a 90-degree angle? And if it's not, then this is not going to be our height. So that's why we see this line here with the dotted line, and this little symbol is our 90-degree symbol. So this actually is our height, and that makes sense. If you've got a building curved, this line here is not our height, this is going to be our height. Kind of like the building, the ROM downtown, that curved side is not the height, but the height straight up and down at a 90-degree angle to the base, that's going to be our height. So our height in this case is 4 centimeters. Let's go on to B. So B, they've kind of tricked us up here. They're making it look like 13 is the base. Well, if 13 is the base, the question is, can this side be the height? Well, again, we have to look at this angle from 13 to the 10, and is this angle 90 degrees? Clearly it's not, so then that's not going to work. We have to look for a line that's at a 90-degree angle. So if our base instead was 10 centimeters, then what would the height be? Well, this line here is at a 90-degree angle to our base, so that's going to be our height. So our height, therefore, is 12 centimeters. Let's go down and take a look at C. So C, well, now we're on the right track. We know what we're looking for. We're looking for a 90-degree angle, and we see that over here. That means this line here could be our height, and this line over here could be our base. So our base would be 4, and our height would be 8.8, not 9, okay, because this angle here is not 90 degrees. That's not a 90-degree angle. Similarly, over here for D, our base is going to be the 8 centimeter line here, because this 4.4 centimeter line, that's going to be our height, because it's at a 90-degree angle to the 8. Now the next question is going to ask us, let's go on to number 2 now, the area of each of those parallelograms. Well, we're going to write the formula down first, the F part, and it is base times height, and then our work showing that we are replacing B with 12, and we are replacing H with 4. So instead of B times H, we have 12 times 4. And our answer to complete our fois will be 48, but we are missing our units, so we need centimeters squared. Let's look at B. Area equals base times height. That's our F. Our work. Base, in this case, it was this side over here, so 10 times our height, the line that was at a 90-degree angle, which is 12. And our answer, our A here, is 120, and we need the units big time. We've got to bring those down, and it's centimeters squared. And that's going to be how we figure out the area. I'm going to skip C and D, and I'm going to go now on to number 3. So on a 1 centimeter grid paper, draw 3 different parallelograms with each base and height. Let's just do this one over here. So we're looking for a base of 3 and a height of 5. So I'm going to get my line tool out, and we're going to create some lines here. Base of 3, well, that's simple enough. There's a base of 3. Now a height of 5. Well, 1, 2, 3, 4, 5. There's my height of 5. And I need a parallelogram. Well, this is kind of going to give me a rectangle here, which is a sort of parallelogram, but not the kind we're used to. So let's see if I can do another one here. So there's a base of 3. Now I know that my height, this needs to be my height right here, but it doesn't tell me how these lines can go at all. So let's try this. Let's try and see what this does here. So over here, we have a base of 3, and we also have a height of 5, because from here to here is 5. And remember, this is at a 90-degree angle here. And that's one example of a parallelogram with a base of 3 and a height of 5. But let's look. I'm going to try some different lines. Let's look at what other triangles we can draw from the same base. I'm going to keep that same base. I'm going to do a red one now. I'm going to move over 1 unit. Well, there's another one. There's another parallelogram with a base of 3 and a height of 5. I'm going to do one stretched way down over here. Let's see how many units I counted over. 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I know I have to go 3 over, so that's easier. Whoops. Let's make another line here. Whoops, it keeps extending that line. I lost my line tool. Here we go again. There we go. 3 over. Now I have another parallelogram here. This looks like a very strange parallelogram here, but in fact, it has a base of 3, and how high is it? Well, if I extend this line all the way at the bottom, if I extend this line at the bottom, and I extend the line at the top, we can see that the height all the way along here still remains 5, no matter where we put it. So here's an example of 3 different parallelograms with base of 3 and a height of 5.